In this video, I'm going to just go over two problems from the PowerPoint um, that are just extra examples for a moles to mass type of conversion and then a mass to mass conversion. If you want to refresh your memory on the foundation of how to do these problems, you should watch the video titled Stoichiometry Day 2 Types of Calculations. Okay, now an equation has been given here to us, sodium and chlorine uh, being synthesized into sodium chloride. You can see that the two coefficients or the coefficients that are present in front of the reactants and products, there's one here. Those are the coefficients that we will be using for mole ratios. If you've forgotten what mole ratios are, watch Unit 8, Introduction to Stoichiometry. Okay? All right, let's read the question. Using the balanced equation, remember stoichiometry always requires a balanced equation, determine the mass of sodium chloride produced when 1.25 moles of chlorine reacts with excess sodium. So the reason that they say excess sodium is we don't really need to know how much sodium there is, it's just a lot, okay? But exactly 1.25 moles of Cl2 is reacting, and they want us to calculate what is the grams of NaCl or the mass of NaCl that's being produced when 1.25 moles of Cl2 is reacted. So we're going from moles to mass, okay? So that means we have to compare chlorine and sodium chloride. This is what we will have to write mole ratios for. Mole ratios are conversion factors where you put chlorine over sodium chloride or sodium chloride over chlorine. Okay, so if you have moles of chlorine, the very next step is to find how many moles of sodium chloride is 1.25 moles of chlorine. So let's set that up. We're going to need two conversion factors, one for the mole to mole ratio, and then the second one for the molar mass of sodium chloride. Okay, so let's write the mole ratios for this. The two mole ratios are 1 mole of chlorine over 2 moles of NaCl, or 2 moles of NaCl over 1 mole of chlorine. So I need the one that will cancel out Cl2. So moles of Cl2 is on the bottom on this conversion factor. So that's what I'm writing here. 2 moles of NaCl on the top, 1 mole of Cl2 on the bottom. Okay, that way moles of Cl2, moles of Cl2 will cancel out, leaving me with the type of moles that I want, which is sodium chloride. Now that I have moles of sodium chloride, I can easily go to grams of sodium chloride by calculating the molar mass of sodium chloride, which is going to be sodium from the periodic table is 23 grams per mole, and chlorine from the periodic table is 35.45 grams per mole. That gives me grams per mole. That gives me this is a 5, a 4, an 8, 58.45 grams per 1 mole of sodium chloride. The reason that I just wrote it like this is because that's what grams per mole is. The per is this division line. It's this line, okay? So I want to cancel out moles of sodium chloride. So 1 mole of sodium chloride go on the bottom, and then 58.45 grams of sodium chloride go on the top. Okay, so this is a new occurrence. 58.45 grams of sodium chloride go on the top. So look at that now. We have beautiful unit cancellation. Moles of sodium chloride cancel out, leaving us with the single unit that we do want, which is grams of sodium chloride. So 1.25 times 2 times 58.45 gives me 146 grams of sodium chloride. Let me actually write it with decimal places. 1.25 times 2 times 58.45, 146.13 grams of sodium chloride. Okay, so we were given moles of chlorine and we went to grams of sodium chloride. We went from moles of one substance to the actual mass of a second substance. The first thing that we did was use the bridge, which is moles to moles, okay? Moles of chlorine to moles of sodium chloride. And then we went to mass using the molar mass, okay? So here we used mole ratio, and then here we used molar mass. Both of those things are things that you have learned. Now you are just applying. All right, let's look at the second question. We are going from mass to mass here. Look at the actual equation. We have ammonium nitrate going to dinitrogen monoxide and 2 moles of water. So the question is asking, let's read it. How many grams of water are produced? That means we are going to end up with grams of H2O when 25 grams of ammonium nitrate decomposes. So they have given us 25 grams of NH4 NO3. We're starting with mass, we're ending with mass. Okay, so this is a mass to mass conversion. If it's a mass to mass conversion, we must always go through moles. So the two components that we are comparing is ammonium nitrate and water. We will have to write the mole ratio because we're going to be comparing these two things in just a minute. Okay, so let's first calculate the molar mass of ammonium nitrate. If you add up all the masses, let's say we have one nitrogen, two nitrogens. So two nitrogens, that's going to be 14.01 grams per mole times 2. I have four hydrogens, 1.01 grams per mole times 4. And then I have three oxygens, so that's going to be 16 grams per mole times 3. If you add this all up, you should get 80.06 grams per 1 mole of this ammonium nitrate. So that's the first conversion here. Okay, I'm going to write 80.06 grams of NH4 NO3 under 1 mole of NH4 NO3. Units and telling me what species you're converting is super important. Okay, we're gonna have three conversions here. All right, now that I have grams and grams cancel out, I have moles of ammonium nitrate. Now it's time to compare the mole ratios. So I have 1 mole of NH4 NO3 over 2 moles of H2O, or the reverse of this if you flip it, which is going to be 2 moles of H2O over 1 mole of NH4 NO3. Okay, so let me erase that. So that means I need to use the conversion factor that cancels out moles of NH4NO3. That's going to be the second conversion factor. So 1 mole of NH4 NO3 go over here. The reason it's 1 mole is because there's no coefficient in front of the ammonium nitrate in the balanced equation. Okay, then 2 moles of water because 2 is the number in front of water in the balanced equation. Now we have cancelled out moles of ammonium nitrate, and we are left with moles of water. One more step to get to mass of water, which is a step that you already are so familiar with, you have to use the molar mass of water, which is going to be 18.02 grams of H2O over 1 mole of H2O. 1 mole of H2O is on the bottom because we want moles to cancel out and we want to end up with grams. Okay, so moles of H2O cancel out. Look at all the nice unit cancellation. You know you're doing the right stoic if the units cancel out beautifully. Okay, so cancel, moles with moles of water cancel out. We are left with the answer, which is 25 grams divided by 80.06 times 2 times 18.02. That gives me 11.3 grams of water. That means when you react 25 grams of ammonium nitrate, you end up producing 11.3 grams of water. We started with the mass of one thing. We started with mass here and we ended with mass here. And in order to get from mass to mass, we went through moles. Okay, so that's super important to know that moles are the bridge that you use to cross from mass of one substance to the mass of the second substance.